All right, welcome back to solving polynomial equations. This is kind of part 2 of the video. First part looked at techniques for factoring. Now I want to show you a couple hints, and then in a third video we will do some examples. So some hints. Like I said before in the first video, always look for common factors. So here, 16y cubed plus 10x cubed. Well, you see perfect cubes in the variables, but definitely not in the numbers. But there is something in common. You can factor out a 2. When you do that, then you end up with 2 times the quantity, 8y cubed plus 5x cubed. That piece here, what's left in parentheses, is considered prime, so you can't factor it anymore. So this would be your final answer. Some problems are going to be that simple for you right now. Then I talked about how factoring by grouping is really, I talked about that in the last video, and it's really the only method that you can use when you've got polynomials with 4 or more terms. You've got to group them in different ways. So here's another example. 4 terms, x cubed plus 5x squared minus 2x minus 10. Now notice when I go to group them, I put parentheses around the first 2 terms, and then I put parentheses around the second set of terms, but I throw a plus in between. Because if I left the minus out, then I'd automatically have to change the sign on that negative 10. And more often than not, people forget to do that, and it messes them up. So I find that it's easier to throw parentheses around each part that I want to group together and put a plus sign in between, and then deal with the negative sign as I'm factoring. So I'm going to look at the first grouping, x cubed plus 5x squared. What's common? And x squared is common. So I factor that out, and I'm left with x plus 5. Now I'm hoping that when I factor the other set, I'm going to be able to create an x plus 5. Remember, we're starting with a plus. What's common here? If you've got a negative sign on that first term, really try and get that out. So I'm going to plot a negative 2. So the plus becomes a minus 2 times, guess what? X becomes positive, and the 10 now becomes a plus 5. I've got 2 of the same terms. Yay! I can factor just a little bit more because now these, the x plus 5s, become the greatest common factor. And I'm going to pull those out, factor them out. What is left? X plus 5 in one parentheses, x squared minus 2 in another. Always check and see, can you factor any more? In this case, you can't, so you're done, and this is your final answer. Sometimes you'll encounter instances where you could keep factoring, but not on this one. All right, couple more hints. I apologize if these couple problems look a little overwhelming. Hopefully, as we actually work through an example or two with them later, these will become a little less overwhelming. I just at least want to show you that they exist, and then kind of let you come back and refer back to this later. So if you're factoring 2 terms and the exponents are 6 or greater, you can really even look at this for when there's 4s, except I won't go into perfect cubes, it'll be perfect squares only. Look to factor perfect squares before factoring perfect cubes. Sometimes that's going to happen, sometimes that's not. But really what I'm saying is, if you have even powers, and this only works with even powers, look and see what happens if you can break them down and essentially you divide the powers by 2. So here, x to the 6th minus y to the 6th. If I divide, so I treated this like a difference of squares, and I divided the powers in half. X cubed plus y cubed, x cubed minus y cubed, because I saw there was 2 terms. And so I looked at it as a difference of squares first, because now look at, I got these down to cubes. Now I can treat these like a sum of cubes and a difference of cubes. And I go follow the pattern from the front for sum of cubes and difference of cubes to get my final answer. So remember, what you're doing is you're looking at even powers and how can you break them down. If you've got two terms, think difference of squares, then think sum and difference of cubes. All right, then the last one. The one that you're looking at going, holy cow, there's a whole lot of writing there. Wow, what am I going to do? Take a deep breath and go, I can do this. It's just going to take a little bit of room and a little bit of time. So let's say you have 6 or more terms. I got 1 term, 2 terms, 3, 4, 5, 6. I'm just going to stop with 6 because that's enough. Group them. The ones that seem to have the most common looking values to them. So an a cubed x squared minus 6a cubed x plus 9a cubed minus b cubed x squared plus 6b cubed x minus 9b cubed. Notice, I have 3 terms that have an a cubed in them and 3 terms that have a b cubed in them. I'm going to group those together. So just look for things that are in common to try to group them together. Then factor out what's common. Pull out an a cubed. I'm left with x squared minus 6x plus 9. I factor out a negative b cubed. I have x squared minus 6x plus 9. Hey, that's familiar. So I can factor that out. And just for ease of how I was writing it, I put a cubed minus b cubed first. You can put them in either order. X squared minus 6x plus 9. But now we're not done. Look at a cubed minus b cubed. That's a difference of cubes. I'm going to follow the pattern from the front to get that factored further. X squared minus 6x plus 9. That was a perfect square trinomial. So I'm going to finish factoring. Square root of the first term, square root of the last term, throw the minus sign in between and put a square on it. So that's just one more hint, one way to look at it. Break things down. Look for as much in common as you can find it. All right, so next video will be all about examples.